Hello all, welcome back. So in this today's class we'll try to design the universal shift register, right? So we'll try to design the 4-bit universal shift register, right? First we'll try to understand what is the meaning of universal shift register, right? So any shift register called as the universal shift register if we perform these kind of operation. One is no change or memory operation, then shifting the data towards the right direction. So it means that shifting the data towards the right direction. So for your right hand it is nothing but the shifting the data towards the right direction. Then one more is the shifting towards the left direction, right? Your left hand side shifting the data toward the left direction. One more is the parallel load, right? So if this operation can be performed by any shift register, right, then this is called as the universal shift register. So what do you mean by universal shift register qualification is that it should perform the memory operation or no change operation. Memory operation means previous present state value equal to the next state value. Previous state is 1, next state also 1. Previous state 0 means next state also 0. It is something like this, we called as the memory or no change operation. So it should possess this quality. Then second one, it should be capable of shifting data towards the right direction, or it should be capable of having the shifting data towards the left direction. Then one more, it should have the capacity of the parallel loading operation, loading the data inside of the flip-flop by using of the parallel mechanism. So these kind of qualities we called as the, right, so who possess these qualities we called as the universal shift register, right? Then one more important point to remember is that as per the previous discussion of the classes, we know that if you want to store the 4-bit information, we require the 4 flip-flop, right? So 4 flip-flop means what flip-flop will do? It will store the information, but if we required, we can shift the data from the one flip-flop to the another flip-flop. Remember, try to remember, this is an important point. The capability of the flip-flop is it will store the value as well as the shift the value, right? Only these two things can be performed by the flip-flops. Now what is my requirement is that if something called as the universal shift register, this should have the, that should be having the capability of performing the no change operation, shifting towards the right direction, shifting towards the left direction, one more parallel load mechanism. Then only that is called as the universal shift register. It means that how many options we have here? 1, 2, 3, 4 options. Then one more point to be remembered here is that at a time you cannot able to perform the four option parallelly. If no change operation being performed, then these 3 should be disabled. If shifting right is enabled, then remaining these 3 should be off. If shift left is enabled, then these 3 should be off. If parallel load is enabled, then these 3 should be off. It means that it should support for all these things, then it is called as the universal shift register. And one more thing is that here we should have the control. Why control means at a time you cannot able to perform the all 4 operation. If one operation being performed, remaining 3 will be inactivated, right? Now if you observe here, what is the capability of the flip-flop? It can store the value, it can shift the value, but it don't have the any something called as the control mechanism, right? So now if you observe here some diagram, we have the 4 flip-flop. What is the use of this 4 flip-flop? Which is used to store the binary information. If required, we can shift the value from the one flip-flop to the another flip-flop. Now out of these 4 conditions, at a time we can enable only one, right? That flip-flop will do that conditions. It have the control operation? No, it don't have the control operation. It means that out of these 4 possibilities, at a time only we can able to perform the one. It means that we should implement the control mechanism. It means that if you observe here, so out of 4 possibilities, 1, 2, 3, 4, at a time only one will be activated, either this one or this one or this one. It means out of 4 only one will be activated at a time. So it means that we should have the control on the 4 possibility to the single output value. This control mechanism cannot be performed by your flip-flops. Now what we required is we required something called as the additional mechanism. If you see that, that is our additional mechanism. Now if you understand here why they have considered something called as the 4:1 multiplexer is that question that you have to remember. Why 4:1 multiplexer means, if you observe this diagram, how many possibilities we have? First one is the something like this. You take some block diagram something. So first one is the no change operation. Second one is the shifting towards the right direction. Then shifting toward the left direction. One more is the parallel load operation, right? Out of this, how many possibilities we will be getting at a time? Only one, right? Now see that how many inputs we have? 4. How many outputs we have? 1. It means that 4 inputs should be converted to the single output. What we call? We have something parallel to serial information or parallel to serial converter, means out of 4 at a time we can able to produce the only single input, means single output, means what it is called as? This is called as the multiplexer operation, right? So out of 4 at a time only 1, it means we should have the control. So now this is what we called as the multiplexer. How many inputs we have? 4 inputs. How many output it is producing at a time? Single one. So this is what we called as the 4 to 1 multiplexer. Now here you need to understand one thing clearly. The use of the right flip-flop, it can store the value as well as the shift the value. But whenever the control comes out of 4, if only one particular thing will be selected at particular point of time, then control cannot be performed by your flip-flop. So for that, what is required? We require some different circuits. In my case, out of 4 at a time only 1 should be enabled. It means 4 to 1. So 4 to 1 means what controller, right? That is nothing but the multiplexer is required. Why here we have the 4 multiplexer means, right? If you observe here, I have the 4 flip-flops, right? So we required 4 control mechanism. First point to be remember is, right? So control can be performed at the multiplexer, loading and shifting can be performed at the, storing and shifting can be performed at the flip-flops, right? So then only you will be understanding the what is the operation of the universal shift register. Now instead of understanding this diagram, first we will try to draw the circuit diagram from the scratch so that you will be understanding easily, right? Now 4-bit universal shift register means how many flip-flops are required? I am going to consider the 4 flip-flop, right? So just for your understanding, so I am going to consider this is the flip-flop 1, this is the flip-flop 2, then flip-flop 3, then flip-flop 4. Then one more point to remember is, what is the input of the flip-flop? DA, QA, right? One more is the clock pulse value, right? Like this we can write, or if I write something like this, DA input here, QA output here, then clock pulse here. The meaning is the same, right? Here we are representing here, here we are representing here. The meaning will be same only for just for purpose, right? So instead of writing the inputs output here, just I am going to write like this. Meaning will not be changed, guys. It will be same only, right? It means that what I am trying to say is I am going to input consider DA for the first flip-flop, right? So second flip-flop DB input, DC input, DD. What is the output value of the flip-flop? QA, QB. I am not going to consider the complement value, guys. Only normal output only I am going to consider. So one more is the clock pulse, right? So negative edge triggering I am going to consider negative edge, right? So all shift registers are the synchronous operation, right? It means that common clock pulse should be applied to the all the flip-flop, right? Now this part is completed, right? So clock pulse is completed. Now what is the use of this shift register means we can store the value or we can perform the shift operation. But what is the meaning of universal shift register? It should have the capability of performing these following operation, right? So no change operation or memory operation, shift right, shift left, parallel load. At a time only one can be performed. It means we require something called as the control mechanism out of the 4 possibility to the single output. So this cannot be performed by your flip-flops. Now what is required? 4 to 1 multiplexer is required. Why 4 to 1? Out of 4 possibilities at a time only one be selected. It means that so no change. If selected, then remaining 3 will be off, something like that. So if we take multiplexer, 4 to 1 multiplexer means what is the truth table? Selection line S0 S1, then output value, right? So if 0 0 is selection line or 0 1 1 0 1 1 selection line means what is the output possibility we will be getting? Let it be 0 0 means no change, 0 1 means shifting towards the right direction. If 1 0 activated means shifting towards the left direction, 1 1 means it will perform the parallel load operation. So how to remember this one, right? So see that 0 0 means no change, you can remember. 1 means 1 1 means parallel load operation, you can remember. So 0 1 means some people will confuse, either they can take the shift right operation or shift left operation. Now simple that. So where we have the 1, right or left? So this is the left, this is the right, right? If we see here we have the 1, then you can consider as the shift right operation, just for remembering purpose. If 1 0 means where we have the 1, right side or left side? This is the left side, this is the so this here we have the 1 right, this means 1 right, this direction we have right. So it means that shifting towards the right direction or left direction, shifting towards the left direction. So 0 1 means this side we have the 1, right, shifting towards the right direction, like that you remember. If selection line equal to 0 0, memory operation will be performed. If selection line is 0 1, shift towards the right direction will be performed. 1 0 means shift towards the left direction is performed. 1 1 means parallel load operation will be performed. What is the meaning of shifting towards the right direction? Means something, if you have the 4 flip-flops, this is connected something like this, right? If we shift the data from this flip-flop to this flip-flop, this flip-flop, this flip-flop, then it is called as the shifting towards the right direction. Now what is the meaning of shifting towards the left direction? Again I am going to consider the 4 flip-flop, right? So which is connected one to another. If you connect from, if you shifted towards this direction, this is what we call as the shift right direction, right? But if you shift from this direction, if you started from this flip-flop, then this is called as the shifting towards the left direction. So from here to here, from here to here, from here to here. Right means this is your first flip-flop, left means the last flip-flop is your data entry or data input value, right? So what is the meaning of parallel load? Load means by default no value will be stored in the flip-flop. So for that, see, first important point is that if you want to perform the shifting data towards the right direction or towards the left direction, what is required? Or memory value, what is required? First you should have some data inside of the flip-flop, right? If you have some data inside of the flip-flop, then only you can perform the shifting operation towards the right direction or shifting operation towards the left direction, right? So ultimate aim is that in universal shift register, first what we are going to do is we are making the selection line equal to 1 1, so that some value we are loading inside of the flip-flop. This is important point. First we are activating the 1 1, so that we are going to storing the some value parallelly. Parallelly means after applying the first clock pulse itself, the 4 values will be stored into the 4 flip-flop. Once it is done, now what operation you want? No change or shift right, shift left, you can happily perform, right? So now for controlling, what is required? Multiplexer is required. So we have the 4 flip-flop, right? So for that I am going to consider the 4 multiplexers, right? So so this is the first multiplexer I am going to consider. For second one, this is the second multiplexer. This is the third multiplexer. This is the fourth multiplexer. So how many input multiplexer will be having, right? So 0, 1, 2, 3 inputs, right? What is the output we will be having? Single output, right? That is nothing but 4 to 1 multiplexer, right? So just I am going to consider something like this, 4 options, right? Option 1 0 0 0 1 1 0 1 1, something like this. So 0 1 2 3, 0 1 2 3, again 0 1 2 3, right? So out of this one, what is required? Something we required the selection line, right? If 4 input means how many selection line? 2 power n, where n represents the selection line, right? How to write the 4? We can write in terms of the 2 power 2, right? Where 2 represent the or n represent the number of selection lines, where 2 equal to number of selection line. So what is the selection line value? S0 as well as the S1, right? So that selection line I am going to consider here. One is S0, another one is S1. For second multiplexer also we have the selection line, right? Right? This is also 4 to 1 multiplexer, right? This is also 4 to 1 multiplexer, right? This is also 4 to 1 multiplexer. So it means that I am going to consider the same selection line. Two more selection line, 2 more selection line, 2 more selection line. Right? Instead of connecting the multiple selection lines, again S0 S1, S0 S1, S0 S1, just I am shorting all those things. It means that the moment if I give some S0 S1 value, this one will be activated, right? So far what we have done, we have given the 2 selection lines as per the 4:1 multiplexer design. Then we have the 4 inputs 0 1 2 3, that is same for the all 4 multiplexer. Then what is the pending one? The output is the pending one, right? Now where to connect the output is, right? Somehow we should have the connection from the flip-flop to the multiplexer controller, right? So first we need to give connection, right? So then these both will be start working together. In flip-flop it will perform the storing and shifting. Here in multiplexer it will perform the controlling operation. So what is our leftover? Input 0 1 2 3 completed, selection line S0 S1 completed. Now output is pending. So where we are going to connect this output means this output will be connected to the input of the first flip-flop. This output is connected to the input of the second flip-flop. This output is connected to the input of the first flip-flop. This output is connected to the input of the fourth flip-flop. So what is this? This is the output, first output, second output, third output, fourth output. Remember, this is the first output value, QA, QB, QC, QD. These are the input value. It means that whenever the selection line is something, it means that if your selection line is 0, 0, which one will be activated? 0, 0 means which one will be activated? No change. No change means what is the value? 0, right? So this one will be activated, this one will be connected to this one. Something like this. If something you are giving selection line 1, 0. 1, 0 means what? 2, right? So this one will be connected to here. Out of 4, this one. If something if you are giving selection line 1, 1, then this 3 will be connected to here. Right? So like this operation is going to be performed. I hope it is clear up to now. Next, what we have to do means we need to perform these 4 operations. Then it will be our universal shift register. Right? Now first what will we do? What we are going to do is first we will perform the loading operation. So out of these operations, right, what is the operations we have? 0, 0 means no change, 0, 1 means shift right, 1, 0 means shift left, 1, 1 means parallel load operation, right? Now we try to tell me what is the first operation we need to perform? 0, 0 or 0, 1 or 1, 0 or 1, 1. In other word, we can say first no change operation or shift right, shift left or parallel load. Which operation first we need to perform? Yes, the answer is that first we need to perform the parallel load operation. Why parallel load operation means? Simple guys, if you want to perform the shift right or shift left operation or no change operation, first we should have the data inside of the flip-flop, right? Then only whatever the operation you want to perform, you can perform, right? So if you don't have any data, then what is the use of performing the shifting data towards the right direction or shifting data towards the left direction or keeping the same value in the same flip-flop? Then what is the need? It is not required, right? So ultimate aim is that in control operation, first we are going to select the parallel load operation. So what is the number for parallel load operation? 1, 1 is the parallel load. Parallel load means what? We are going to insert some data into the 4 flip-flop. Parallel means for single clock pulse, we can able to store the 4-bit information inside of the 4 flip-flop. So now what I am going to do is in the first step, I am going to activate the 1, 1. 1, 1 means parallel load will be activated. So 1, 1 means nothing but what? 3. Right? 1, 1 means binary number 1, 1 means it is the decimal number 3, right? So parallel load is activated. Let it be, I am going to store the value 4-bit number, that is 1, 1, 1, 1 inside of my this first flip-flop, second one, third one, fourth one. Right? Now out of this one multiplexer, which one should be activated now? 0, 0, 0, 1, 1, 0 or 1, 1. What is the first point I am going to do? I am going to perform the loading operation. For loading operation, what should be the selection line value? 1, 1, right? It means that by default, this will be activated, this will be activated, this will be activated, this will be activated. Now, which one we have given the priority over this? Out of 4, the priority will be given for the 1, 1. It means that I am giving the selection line is 1, 1. Now, which is activated? Something 3 will be connected to here. No, 2, 1, 0 will be connected to here. Only 3 will be connected to here. Something like this. It means that whatever the value 3 is connected to here, this will go inside of the your flip-flop, that value will be stored here. The same way 3 will be go here, the value will be stored here. Same way here 3 will go here, the value will store here. Same way the value will be stored here. So what is the meaning of 3? Parallel load, right? 1, 1 means. So it means that this connection we are going to insert some parallel data, right? At the line number 3, parallel data. Let it be P0, let it be P1, let it be P2, P3. What is the data I am trying to insert? 1, 1, 1, 1. Simple point is that when selection line equal to set to be 1, 1, 3 will be connected to this one. Right? Now what is the data of P0? 1, right? It means that 1 will go to here. Right? So 1, 1 is enabled means these 3 will be connected to here. The same 1 will go to here. This is go to DA. Then it is stored in the flip-flop. Now what is the output of this one? 1 is the output. The same way this one will go here, 1 will go here, 1 will go here. Now what is the value which is stored in the flip-flop? After enabling the 4 parallel load operation, 1, 1, 1, 1. The ultimate idea here is that we are going to load some value inside of the flip-flop by using what? Parallel load operation. So for that, what is the selection line value? 1, 1 is the selection line value. Now what is the data we have inside of the flip-flop? 1, 1, 1, 1. Now you can see whatever the operation, if you want to perform no change, you can do it. Shift right, you can do it. Shift left, you can do it. Right? Now what we will do is, first we will perform the no change operation, right? After this one load is completed, now we will perform the no change operation. So what is the meaning of no change operation? Means let it be in the flip flop, DA is the input, QA is the output value. If it is 1 means for the next clock pulse also what should be the output no change means, if it is 1 means next also 1 only, right? Again no change means next clock pulse also 1, again next clock pulse also 1, right? This is what we called as the no change operation or memory operation, right? It means that when control is connected to the input, this same value will be output. For next clock pulse also it should be in the same flip flop. That 1 will be always remaining in the same flip flop. Next clock pulse also it should be same. Next clock pulse also it should be same. Next clock pulse also it should be same. So if it is same, and it means that the same flip flop value should be stored by the same flip flop only. Then it is called as the no change operation. If you connect somehow here to here, it means that you are shifting one value into the another flip flop. Then it is called as the not called as the no change operation. No change means same value will be stored here, again will be shifted to here, shifted to here, shifted to here, right? It means that the same value will be here means then it is called as, even though multiple clock pulse, then it is called as the no change operation, right? So first what we will try to do is we will perform the no change operation. For no change operation, what should be the selection line control mechanism? 0 0 should be control mechanism, right? Now what is the value currently stored in the flip flop? 1 1 1 1, because first itself we have performed the parallel load operation. Now which is enabled? 0 0 means what? No change operation. So out of this, which one will be activated now? This one will be activated. This one will be activated. This one will be activated. This one will be. Why this one will be activated? Because selection line is the 0 0, right? That point you have to remember. Now this is activated here means something like this. This is activated here means now this will be connected to here through the multiplexer control to DA, right? So what is the value here? 1, right? What is the output value? 1, right? Now what will be happen means this value will again go to no change means what? This value will be again go to 0 only. Now if you apply the one more clock pulse, if you are giving the input 0 0, again this value will be here only. It means that see, control is performing at the multiplexer, shifting and storing is performing at the multiplexer. Even though if you apply the multiple times also, first it is storing in the shifting, control is performing at the multiplexer. So it means that the 1 will be remains in the same flip flop only. This is what we called as the no change operation. Ante meaning endante, if the value is being stored in the first flip flop, the value remains in the first flip flop only. That is what we called as the no change operation. So how to draw this one? So this one, the output will be connected to the control of the 0, then same value will go to here. For the next clock pulse also it will repeat. For the second flip flop, 0 will be connected to here, right? For this is for first flip flop. For second flip flop, how it will be? Again same, right? So this one will be connected to here, then same will be go here, then this one will be the output of this one is connected to the controller. What is the controller? 0. For the next clock pulse also it will be same only. For next clock pulse also it will be same only. If the value is, see why we are, instead of connecting something like this, right, why we are coming through the multiplexer means because 0 0 we have control operation here. That's why reason everything should be come from the through controller to the flip flop, right? If you take the right, so third flip flop, so data will be again in the same flip flop, right? That is what we called as the no change operation, right? So the again if 0 will be activated, something like this, now same 0 will go to here, this will produce the output, nothing but this is the 1, then again this will be going to stored in the 0, again it will be going to here. The same way for the fourth multiplexer also it will be 0 will be connected to here, the same value will be go to here. So this operation we called as the no change operation. Now what are the operations we have completed? One is shifting, parallel load is completed, another one is the no change operation is completed. Now first we will try to see what is the meaning of shift writing. Once it is completed, we will see how to perform the shift left operation. So now what we are going to do is we are going to perform the shifting towards the right direction. Shifting towards the right direction. So what is the meaning of shifting towards the right direction? If you have something 4 flip flops, right, how to shift? Which is the first flip flop for shifting towards the right direction? This one is the first flip flop, right? Shifting towards the left direction means what is our first flip flop? this one is your first flip-flop, second, third, fourth, something like this. Now we are going to shift the data towards the right direction. For that, what is the control symbol? So 0 1, right? In multiplexer, which one should be enabled? 0 1. So it means that this one will be activated. So if you observe here, so first we have the 4 flip-flop, right? So how to perform the shift right operation? Serial only, right? So it means serial only, right? As we discussed in the previous classes, how to design the serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out, right? So it means that how many bit value we can give at a time? Only 1 bit value. Because serial in means we can enter only one data in. This will be stored here. This data will go here. This data will go here. This data will go here. Finally, you will be getting output. Simple thing. So shift right means we should be enabled 0 1. So I have given the selection line as the 0 as well as the 1. Now which one will be activated? The control line 1 is activated. So this is what we called as the shift toward the right direction operation, right? Now suppose for example, if we give here external data is 1. Now what is the value here? The 1 will go to here. It will store here. Now what is the value here? Already we have 1, right? Now where this 1 will be shifted? It will be shifted to here, right? But directly it will not shift from to here, but it will shift through the controller. That is point you have to remember. Everything will go through the controller from the one flip-flop to another flip-flop. Remember one point, shift right means I am giving some external data, let it be 0. Now 0 means if 1 is activated, this one will go to here. Now this value will be 0. Already what is the previous value which is stored in the parallel load 1, right? Now it cannot able to store the 0 1, right? This value should go to here, right? But here the value will not directly go to from to here to here. First what we'll do means the output will be going towards this control line. So from this control line to this will be go something here, right? So let me explain clearly. Now what is the data we are giving? 1 or 0, your wish, 1, right? Now this one is activated, right? So this 1 is activated means the same value will go to here. So now what is this value? 1, right? So already we have 1, right? It will be shifted to here, but how? First it will go to the controller of the second flip-flop multiplexer, then it will go to here. So that value will be stored from here to here, not directly from here to here through the controller, right? So where it is generating the output value? Here it is generating the output value. This output what we are going to do is actually same no change output value is there, right? This we are going to connect it to the, what is the line we have to connect? 0 1 means 1, right? This will be connected to here. Now this one will be connected to here. So this will go to here. This will generate the output. This output again we are going to connect it to the first one because 0 1 is activated. This will be connected to here something like this. Now this value will be go to connected to here. Final. Fourth flip-flop. Now here we will be getting the final output value. Now see that shifting is performing right from here to here, not directly from here to here through the multiplexer control. So see that first we are giving the external data, then data is shifted from here to here through the controller. Always we need to take the 1 only. Why 1 only means? Because 1 is for shift right operation, right? Because control also we have given the 0 1. So if you connected something like this, then it is called as the shifting towards the right direction. Now what is the pending operation? Shifting toward the left direction, right? What should be the control value? 1 0. 1 0, right? So now what I am going to do is I am going to give the, right? So shift towards the left direction, right? So 1 0. Now try to understand. So what is the first flip-flop for shifting towards the left direction? Not this one, guys. The first flip-flop is the shifting toward the left direction means this is our first flip-flop. It means that we should not start from here. We should start from here. That is a point to be remembered. So what is the 1 0 means what? 1 0 means 2, right? So it means that 2 we are going to perform for the shifting towards the left direction. Suppose if you are giving the value equal to 1, this will go to here, then it will produce the output, right? This output where we have to connect it. If you want to send the data from here to here through the multiplexer, right? Through the multiplexer of what? Second flip-flop means second controller. So this will come to here. This will be connected to second one. Again this one will be connected to here. Again this one will be connected to second one. So this will produce the output. This output will be connected to the second one. So finally here we will be getting the final output value. This is what we called as the shifting towards the left direction, right? So now let me explain one more time so that you will be understanding properly. In the same multiplexer we are going to perform the multiple operation, right? it is something like this, right? So first what I am going to do is, first I am going to load the value. So load the value means what should be the line? 3 should be activated. So selection line should be 1 1. So whatever the data you are giving here, the same value will be loaded inside of the corresponding flip-flop through the controllers. One is done, first we will perform the no change. No change means what? The same value will be here only, but here everything will be performed by the controller through, right? So this way it will come to the controller first 0, then it will again connect to here. For the second also, first we will control to here. Why we are connecting here 0? Because 0 0 means no change operation. This will go here. Next clock pulse also the same loop will be performed. So this is for the what? Second. Third. This is for the fourth multiplexer, right? So this is what we called as the no change operation. No change operation is completed. Now we will perform the shift right operation. Shift right operation means this is the starting flip flop. Now what should be the enable line? 0 1. Selection line should be 0 1. It means that 0 1 means 1, right? So it means that this 1 will be activated. So here we are going to perform the operation shift right. So here we can give the external data, right? 1. Suppose if we are giving the 1, it will go to the multiplexer, through multiplexer to the flip flop. Now what is already value 1, right? Where it should shift? It should be shifted to the next flip flop, right? Not directly from here to here. Through the controller of the second multiplexer, it will go to the second flip flop. That is the reason why we have the controller, right? Now what will be happen means, right? 1 will be activated here, 1 will be connected to here. So this output where we need to shift to the second flip flop. But how to shift? By using of the controller. So controller which line? 1. So again it will be shifted from here to here. This will produce the output, right? So this output we connected to the again 1. So it is going to perform the shifting operation towards the right direction. So this we are going to connect it to the 1, right? So this is our final output. Now what is the next one? Shift towards the right direction, right? So 2 means this is the shifting towards the left direction, right? So if we give 1, this 1 will go to here. This data should be shifted from here to here, right? So not directly through the controller, right? So it means that this will produce the output value. This output where we have to connect it, this should be connected to 2. Again it will produce some output value. This output value where we need to connect 2. Again it will produce the output. This value we need to connect it to the 2. Where it will produce the output, this is your final output value. Now see that what is the operation it is performing? No change. Then it is performing the parallel, load operation, no change operation, shifting towards the right direction, shifting towards the left direction. This is called as the universal shift register, right? So like this we need to draw the block diagram representation. So this is the final diagram for the universal shift register, right? See, we have 4 flip flops, then 4 multiplexer. So first we are going to perform the parallel load operation. So here we are going to enter the data P1, P2, P3, P4. Once it is done, for the what is the selection line should be 1 1. Next we need to no change operation, right? No change operation means the same value will be here in the same flip flop 0. The second one will be same in the 0. Third one will be 0. First you do like this, right? So once it is done, for the same line what we are going to perform the shifting towards the right direction, right? So for that what is the data should be activated 1, right? So whatever the output, the same no change line is there, right? That you extend to 1, right? Again the same no change wire you extend to 1. Again same, this no change wire is there, right? You extend to 1. So this will become the shifting towards the right direction. Now we have the same no change wire is there, right? Shifting towards the left direction means this is 2. Shifting towards the left direction. No change wire is there, just you connected to the 2 here. The same no change wire you connected to the 2. The same no change wire you connected to the 2. That's why it will become the no change shift right shift left parallel load, right? So it will be look like some difficulty, but if you practice this you will understand, right? This is the most important question in exam point of view. I hope you understand. Thank you.